x plus 3, so we get x back. Okay, so this is actually a fairly trivial case. It is almost the same as the previous one. Yes? Go ahead.
What happens if f of x does not have an inverse function?
We'll deal with that, as another step. But in this case, we'll assume that there is an inverse function. Okay. Okay, very good. Now that we have an inverse function, we are ready for the next step. The next step is completely mechanical. I would say figuring out the inverse function is the most difficult step of this entire procedure. The next one was step 3. Step 3 is to apply the substitution mechanism, method, whatever. Okay. Now, what do I mean by that? So this is the cool part. You can say that post 65 in this case is the result of some kind of mysterious substitution operation. We are taking pre-65 as the origin of the post condition. We will find all occurrences of x, which is the left-hand side of the assignment, and we'll replace it with f prime of x. Okay? So once again, let me explain that again. The sub here is nothing more than a notation to say that we are about to perform a substitution operation. But in order to specify a substitution operation, we need to specify 3 things. The first thing is, what is the original? The original is pre-65, which is given to me. What are we trying to find in the original item? We're trying to find all occurrences of x in this case. What are we replacing x with? We're replacing x with the f prime applied to x. Is that okay? Okay. The next step, the next few steps are completely mechanical. It is just expanding the operation, expanding the conditions. What is pre-65? Well, pre-65 is given here. So I would just copy and paste the whole thing. And we're substituting x with f prime of x. But what is f prime of x? F prime of x is x minus 3. So we put x minus 3 here. Okay. Can everybody follow from the first step to the next? The first step is basically saying, by definition, we have to perform these operations. The second step is just an expansion on the first step. What is pre-65? Oh, pre-65 is this junk here. It is given to me. What is f prime of x? F prime of x is x minus 3, and we proved that that's the inverse function already. Is that okay? Then the next step is really just carrying out the substitution. In other words, within the original item, within the precondition, so I'm going to copy and paste the precondition here. Every time you see an x here, you replace it with x minus 3. Every time you see an x here, you replace it with x minus 3. It is completely mechanical. There's no need to explain anymore at this point. Okay? So after this, you can optionally do some simplification, but that part is completely optional. Is this making any sense? I mean, if you just think about the case-by-case example that we went through, and then you look at this mechanical procedure, are they making any connections? This is really just the same thing, except it is more rule-based now. Oops. Oh, there we go. And I'll just go ahead and add here. Simplify if you feel like it. Okay? In other words, this is a solution that I'm looking for. Somebody asked, what if in step 2, f of x does not have a inverse function? Okay? So we'll handle that part here. This example does not apply, so we have to use another example. So we'll use another example to illustrate what to do when the function has no inverse. So we'll use another example here. Line 90, x gets 5. Okay? We'll say the precondition of line 90 is x is different from y, and y is greater than z. Okay, well, that's sufficient for our illustration, so we'll just keep it like this. Okay? So step 1, same thing. Step 1, use the right-hand side of the assignment to define a function. In this case, we'll define f of x to be 5. Step 2, try to find an inverse function of f of x. None exists. Okay? So the question is, what do we do now? This is the step that will lead to the divergence between the first case and the second case. So in the second case here, in step, I'll call this 2.2 because it is a step that we have not, I don't want to reuse the same numbers as before. Step 2.2 is to apply the forget operation. Okay, so the post condition of line 90 is the result of forgetting something in the precondition of line 90. What are we forgetting? Well, in this case, we're forgetting everything that mentions x because we are changing the value of x, so the relationship of x to the other variables cannot be held anymore. It's not guaranteed to hold anymore. So we're forgetting any component that has x in it, but at the same time, we also know something new now because we know for sure that x equals to 5 at this point. Is that okay?
You just told to forget that x equals 5.
I'll expand it. Once we expand it, we'll see what it means. But basically, x equals 5 is not a part of pre-90. This conjunction is outside of the result of the forget operation. So now the next thing we need to do is to expand what is pre-90. Pre-90 is this expression here that was given to me as an assumption, and we just copy the rest. The forget operation forgets all the components that has the variable that is listed here. So if you look at this expression here, this conjunction here, the first part of the conjunction does have mentioning of x, but the second part does not have any mentioning of x. So the result of the forget operation will keep the second component, but get rid of the first component. So after the forget operation is performed, we have only x is greater than z left. Y is greater than z, excuse me. But we also know something new now because we know now that x equals to 5. So that's the forget operation. With all the homework assignments that you will be doing for this class, it will fall into one or the other case, and they'll all be very simple cases where either the forget operation or the substitution operation will solve the problem. In real world, on the other hand, depending on the complexity of the precondition, there are special cases where just blindly applying the forget operation will not work. But for this class, since we're just getting an exposure of what is the precondition, what is the postcondition, and stuff like that, we'll just keep it simple, and we'll just go with the more mechanical method to solve the problem at this point. Do we have any questions about the pre- and post-conditions and the mechanical method to decide which way to go? Should we use the substitution rule, or should we use the forget rule? No? Yes?
Can you explain again why the y is greater than z is still in the statement when it's kept as being something separate?
The question is, why do we keep y is greater than z even though we have the forget operation? The answer has to do with line 90 is only going to affect x.
Okay.
It does not affect y, it does not affect z.
Okay.
So the relationship between y and z should not be changed at all.
Okay.
Yep.
So if that's the case, then why do we include y is greater than z at all in the forget statement?
Because that is a part of the precondition. You have to, because you want to make this as mechanical as possible. So what you do is you put the entire precondition here, and then you specify, I'm forgetting all the components that contains X. That's the definition of the forget mechanism. Is you take the entire expression, everything that mentions X, you get rid of it. Okay? Now, remember in this class, we use a very simplified version of these derivations, and that's why we can have these rules. When you're working with a real program and you try to apply these techniques, sometimes you have to get out of these rules because there are special occasions where blindly applying a forget rule or a substitution rule may not be the best thing to do. Okay? But as far as your homework assignments are concerned, this is the way to do it. So let me just kind of go back very quickly to show you what we have covered at this point. Of this entire module, we are done with constant assignment. We are now done with simple self-referencing assignments as well. The next one is going to be conditional statements, which is actually fun because now we are looking at the post condition of a branch. We come in here, we ask a question, we decide which way to go, we do something over here, we do something else over here, then merge again. Can I say something about the post condition of the entire thing? That's the question. Okay? So on Wednesday, we'll talk about how to get to the post condition of a conditional statement. It's going to be a little bit more interesting, and then we can start to prove the correctness of the algorithm that finds the maximum of two variables. What? Don't worry about this. I'm going to save it anyway. Plus, there's a video clip. Oh, I better stop the recording. It is still working.